Hey, welcome to 9.6, Solving Rational Equations. So today is kind of the summary section where everything we've learned so far we're going to use in order to solve equations. So to start off with, I want to remind you how to cross multiply back from algebra 1. So I've set up some proportions here, and I'm hoping this will be easy for all of you. I want to try to solve for x. In order to do so, I can do something called cross multiplied. And what I mean is 4 times x, which is 4x, is equivalent to 3 times 16, which is 48. That's what I mean when I say cross multiply. Once you do that, solve for x. So I'm just going to divide both sides by 4, and I end up with 12. Let's do one more, and then we'll move on to the next thing. So multiply across. Diagonally, 5 times 64 is 320, and then solve for x. We are going to cross multiply today to solve our rational equations, but it's going to be a lot more complicated. Let's look at part A for example 1. So I'm calling it method 1 because in this situation I just have a single fraction on each side. If you quickly look to the bottom of your page, see how these have more than one fraction on a side? So these ones down here in example 2 can't be used. We can't use the cross multiply method. To use this cross multiply method, I have to have just a single fraction on each side. So here's what I'm going to do. I'm going to cross multiply. It just looks like more happens because it has, there's more variables and symbols, etc., etc., etc. So 2 times x minus 1 is 2x minus 1. And then on this side, I've got x squared minus x. Now, I haven't yet distributed the 2. The reason is, oftentimes, these problems, something can be simplified before I need to solve it. And here's what I mean. If we actually factor the right side, so look at this, an x is in common, and the remainder is x minus 1. Now, that's going to make this a lot easier to solve because see how both sides has a x minus 1? And both of them are multiplied by whatever else I've got. So if I divide both sides by x minus 1, and then I try to solve the equation of what's left, actually there's nothing for me to solve, just x equals 2. So again, wait to distribute or FOIL or whatever until you see what you have that can be canceled on both sides. Today, with section 9.6, we will actually be checking our answers. Previously, the book maybe said check and we didn't do it because it wasn't really important. But today, we're often going to get extraneous solutions, so we will be checking every problem. So when I look at 2 equals x, let's just quickly throw that in here and see what happens. And the reason we get so many extraneous solutions is because I have x on bottom of a fraction, so often we're going to have a 0 when I try to plug in the solution I got. But in this situation I got 4 minus 2, which is 2. Yeah, we're good because it's 1 equals 1, so there's no extraneous solution for part A. Next I want you to look at part B. See here how I factored after the fact? If you have something that's a little more complicated, it will be to your advantage to actually factor before you cross multiply. Let me show you why. I factor the top, divide out a 4, left with x, and then minus 3. I'm going to factor the bottom. This one is a trinomial, so I'm factoring it to 2 binomials. I want two things that multiply to be 24, but add to be negative 11. So multiply to be 24, but add to be negative 11. It's 3 and 8. And now the reason I wanted you to wait again is often the ones you get in their book, if they're more complicated, something will be able to cancel before you cross multiply. And you don't have to do that step first, but it does make it a vastly easier problem if you cancel it before cross multiplying. So in this situation, I can just pretend right now like I just have the left fraction. X minus 3 and x minus 3, there's one on top, one on bottom, so those just cancel right away. And now I have this. 4 divided by x minus 8 equals 6 over x minus 1. Now if I cross multiply, I can see nothing else is going to cancel, so I'm doing 4 times this whole parentheses, so that would be 4x minus 4. For my other diagonal, 6 times x minus 8, that would be 6x minus 48. Now it's an easy equation to solve, so let's get all our variables on one side, numbers on the other. I will subtract 4x from both sides. I get negative 4 equals 2x minus 48. I'm going to add 48 to both sides. I get 2x equals 48 minus 4 is 44. Divide by 2. And really quickly, let's check. And mainly when we're checking, we're looking to see if I can plug in x and get it to be 0 on bottom. So you can see right away that if I plug in a 22 on the right side, that's going to be fine, because 22 minus 1 is 21. We just don't know if on the left side it's going to work out. So you don't always have to check the whole problem. I'm going to write down this bottom part. That's what I want to check. So let's type that into our calculator. That's what I'm doing right now. 22 squared minus 11 times 22 plus 24. That ends up being at 266 on bottom. So we are going to be just fine for that problem, for that solution. What we just did, parts A and B, that's the cross multiply method. Again, you can only use it if there's a single fraction on both sides. So if there's more than one fraction on both sides, I said our method is to multiply through by the least common multiple. Often that is kind of too complicated. So here's what I want you to write. We're going to find a common denominator will be our goal. We will find a common denominator, and then something special will happen which will make the problem very easy, and I will show you what I mean. So our first step is to make everything have a common denominator, and this is like what we're doing in 9.5, only now there's 3 bottoms to look at instead of just 2. So notice I have a x, and I have a 2, and I have another x. Alright, since these 2 x's, there's just a single one under each, so we don't have to use it twice. This one then, I need a 2 because this one's lacking a 2, this one's lacking an x, and this one is lacking a 2. Now, let me just tell you that sometimes you might not be sure if you have used the correct things you're multiplying by. So here's how you can check yourself. If I go through right now, on top, on the right side, I got negative 22 over 2x. On the left side, I have 5x over 2x and 8 over 2x. You know you used the correct fractions to multiply if these are all the same. That's your goal. And notice how I didn't have to use an x. I didn't have to put another x here and another x here to make it happen because both of them had an x already. Only this one was lacking the x. And that's something that comes with practice. I want to tell you though that once all of these are the same, it's basically as if, well, I'll show you the longhand way first and then I'll show you the shortcut, so don't write this down. But the longhand way is if these are the same on this side, I could add them together. And now it technically is something I could cross multiply. But because there's a 2x on both sides, the 2x cancels, and I'm just left with negative 22 equals 8 plus 5x. So here's the shortcut. If you have an equal sign, and this only works if you have an equal sign, okay? But if you have an equal sign, every fraction has the same denominator. You can just pretend like the denominators aren't there and just use the numerators and then solve that equation. And what you're technically doing is multiplying through by the least common multiple. And when I multiply through by 2x, everything cancels and I'm just left with 8 plus 5x equals negative 22. So shortcut, as soon as you get all the bottoms the same, they all cancel, just have the tops to solve. And now it's an easy equation. Subtract 8 from both sides. I get 5x equals negative 30. Divide by 5 and x equals negative 6. Again, we're going to check it. So I end up with 4 over negative 6 plus 5 halves equals negative 11 over negative 6. And you can kind of tell this time that this is going to be just fine because there's nothing on bottom that's going to make me get a 0. on bottom. Can't have 0 on bottom of a fraction. It's undefined. But when I put in a 6 for x, that's totally fine. If you type this into your calculator, you'll see that they match. Let's do another one. So example B. Again, I made a problem here that's very similar to what we just did with A. So if you feel like you got it, try it on your own and fast forward. But I'm going to go through it right now for people who aren't as fast. First thing I want to do is get a common denominator for all of these fractions. So what I notice is this one has an 8 to this middle fraction, but these two do not have 8s. So for these fractions, I'll multiply by 8 over 8. And then I notice that both of these fractions have an x, and this middle fraction does not. So I'll multiply that middle fraction by x over x. So let's see what we're getting then. 8 times 3 is 24. 5 times x. 12 times 8 is 96. And again, as soon as you get the common denominator, you are really technically multiplying through by the common denominator to cancel these out. Shortcut is we'll just cancel it. I am going to solve this equation by subtracting 24 from both sides. And I end up with negative 5x equals 72. Make sure you don't drop your negative by mistake. Divide by negative 5, and you end up with a decimal. That's okay. That happens sometimes. So I have negative 14.4. And again, we can tell that this solution is going to be fine because if I plug it into the x's, I'm not going to have 0 on bottom of a fraction at all. But let's go through and check it really quick just in case. And feel free to use your calculator when you're checking. So write it down, but then use your calculator to type it in. And when I typed it in earlier, I got negative 0.833 on each side. Check. All right, flip to the back. We'll do example C. So now look at example C. Again, I'm trying to get a common denominator. First thing I notice is that 7 does not have a denominator. So just be smart. You guys all know 7 is the same thing as 7 over 1. Alright, so these ones are lacking a 1, but you know what? When I multiply by 1, it doesn't really do anything, so you don't have to worry about that denominator. We just need to make sure the 7 has an x minus 2 on bottom. So the only thing I need to do this time to get a common denominator is to multiply 7 by the fraction x minus 2 over x minus 2. So this part here we didn't change. This middle part we did. So I have a 7 times a x minus 2, and I'll distribute that. So 7x minus 14. Make sure you have that down correctly. Again, pause if I'm going too fast for you. Multiply everything through by x minus 2, so all those cancel, and now I have 5x equals 7x minus 14 plus 10. So 5x equals 7x minus 4, and then go through and solve it. So subtract 7x from both sides. Negative 2x equals negative 4. Divide by negative 2, and x equals 2. Last but not least, check our solution. And it just so happens that this time, when I throw a 2 in here, I'm going to get a 0 on bottom. Can't have a 0 on bottom. So that is considered an extraneous solution, and if you are checking the answer key in the back of the book, they wouldn't say that. They'll just say no solution for the answer for that problem. Thanks for listening. I'm going to catch you with video 2 starting with part D.